And welcome everybody to the Daily Space Weather. Feeling a little bit under the weather myself today. This is going to be the only video we're likely to put out here at the Smash News Network, least busted name in news. We're starting things out looking at the sun. And thanks for stargazing with us. This is the colorized magnetogram. And we've got some increases in solar activity here. Geomagnetic storm conditions have just subsided. It's what you would call an uptick. These sunspots have grown. This imagery here is of yesterday and today so far. And let's add 171 angstroms to that. There's ionized iron on top of the colorized magnetogram. Again, a slight uptick in solar activity here. So here's the last about 2.5 hours from the GOES 16 SUVI. That's 284 angstroms. And interestingly, you can actually look at the thematic map too, which is always nice. The thematic map on the GOES 16 SUVI. It'll show you different solar features. If it indeed loads. Anyway, that's what's currently going on. The likelihood of solar flares very high. You can see some prominences here, especially on the eastern limb, also some in the northwest. We've got some North Pole oriented coronal holes. We'll get to it all. We'll even cover some meteorology at the end of the video. The 10.7 centimeter radial flux now up to 121 solar flux units. There's the 1-year chart of the radial flux. Again, pretty significant solar uptick here. And here's our space weather enthusiast dashboard. And NOAA calling for pretty accurate depiction there of geomagnetic storm conditions this morning. Again, they have subsided pretty much as NOAA forecasted here. We'll get into more detailed information about that shortly. First, let's take a look at global seismicity, and we're due for a large earthquake here on planet Earth. If you look at these historic graphs, you'll see earthquake droughts tend to end in large earthquakes. So you can see a very long drought here in 2019. There's 2018, a very long drought there. And see what happened after this long earthquake drought. An 8.1 at Fiji. So there's your earthquake drought. Only 1.7 magnitude earthquake over the past 90 days. A little bit of an earthquake uptick here around the Pacific Rim. No major quakes. Keep in mind, any earthquake can be a foreshock. Don't get caught out. And we actually do send out email alerts for things like tsunamis at smashamash.com/smashteam. Just sign up for the email pushes list. Largest quake of the past 24 was this 5.4 at Vanuatu. There was also a 5.2 at Papua New Guinea and a 5.2 in the Aleutian Islands. That one came in as we were doing show prep. So no major quakes. Earthquake drought continues. Let's look at volcanoes briefly. Abico is a flight level 100. It's a 10,000 foot ash plume coming from Abico, 6,000 foot ash plume from Suwanosejima, 23,000 foot ash plume over Colombia from Nevado de Ruiz as it explodes. Sangay in Ecuador also exploding, flight level 200. It's a 20,000 foot ash plume over Ecuador from Sangay, and a 14,000 foot ash plume over Ecuador from Revenador. Two explosive volcanoes there in the nation of Ecuador. And Sabancaya exploding, flight level 230. It's a 23,000 foot ash plume. Please don't pole vault the caldera. Today's featured product is Do Not Pole Vault the Caldera. Check out our merch. Check out smashamash.com. This is where our typical first daily space weather video ends. And now we will move on to the video that you typically see only as a YouTube exclusive. So here is the last 24 hours of solar magnetogram and visible light. And there has been a little bit of sunspot growth here over the past 24 hours. Mostly stable. Let's take a look at the earthly geospace. This is the last 4 hours of magnetohydrodynamic pressure, modeled by the Space Weather Modeling Framework. And we should see the pressure drop here just a little bit toward the end as geomagnetic storm conditions have subsided. See a slight drop in the pressure happening there. Let's take a look at ground magnetic perturbations next. Earth's magnetic moment from the ground. And let us know if you saw aurorae. Hit us up on Twitter or Instagram. We'll feature your photos or videos on the channel. Just drop us a line. And thanks to everybody who interacts on social media. That's the last 4 hours of Earth's magnetic moment from the ground. So planetary K-index now down to 3, coming down off of a significant geomagnetic storm there. A fairly lengthy coronal mass ejection strike. And here's your real-time solar wind. We did see another recent uptick in the solar wind density, making it up to about 34 protons per cubic centimeter. So some additional plasma showing up there. And let us know in the comments if you think this is going to be a coronal hole high-speed stream or a CME. If we see the solar wind speed coming up here, could be a coronal hole wind stream. Not exactly sure, but the current conditions are about 12.7 protons per cubic centimeter for the solar wind density, solar wind speed 416 kilometers per second. The magnetic field right now at 12 nanotesla. Also, we did see an increase in the plasma temperature. This bottom line here, little uptick in the plasma temperature just ahead of this small uptick in the solar wind density. Continuing on to magnetic data. There is your GOES magnetometer readings over the past 3 days, and you can see some very sawtooth readings showing up there on the GOES magnetometers. That is because of a bunch of plasma from space. And thanks for leaving a comment, TinMan1057. Good morning to you as well. So this video was originally streamed live to Twitch. It's twitch.tv/smashamash. There is the page. Thanks to our followers over there. And also make sure you follow us on Twitter. You may see things you won't see otherwise. If you become a Twitter follower, twitter.com/smashamash. We put out alerts occasionally on Twitter, but the best way to get alerts from us is to join the Smash team and sign up for the email pushes over there at smashamash.com/smash team. We appeared in Tamitha Scove's live stream chat yesterday. It was very nice. And we sent out an email alert yesterday about the expected KP6 and Tamitha's live stream. Shout out to Tamitha. Today's featured product is Do Not Pole Vault the Caldera. It's a public service message brought to you at massive personal risk and expense from Smash staff and I. If you're going through hell, keep going. That's a quote from Winston Churchill. Our finest days lie ahead, so don't pole vault the Caldera. It could be unhelpful, and we need the views on YouTube. This video does appear on Twitch, on YouTube, and on BitChute. We changed up the format a little bit today because, well, I felt like death yesterday. And while I'm feeling a little better, not good enough. So press like, subscribe, press the share button. If you're an influencer, drop us a line. We'll be more than happy to appear on your channel, and we'll be more than happy to bring you on ours. Thanks to all of the other YouTube channels who've helped us out over the years, and thanks to all of our YouTube viewers. Smashamash.com is our homepage. Welcome to the Neo Renaissance. Congratulations on realizing that the content exists. Facts. Now controversial because it's the year 2022. Last but not least, I'd like to refer you to spaceweatherwoman.com, Tamitha Scove's own domain. So check her out. She's got a great YouTube channel as well. She's also got an email list and so on. Shout out to Tamitha. And she did do an impromptu live stream yesterday about the geomagnetic storm conditions that arrived. It's magnetic, like the rest of this data. So here is the heliospheric current sheet from the Gong 2 data. Earth remaining solidly in a North Pole current sheet, shown there in green. Here's our line of sight plot, and we've got some Earth-facing North Pole-oriented coronal holes here ahead of those sunspots in the east. That's your line of sight field plot. Moving into coronal holes, here is the coronal hole line of sight plot. You can see those green colored coronal holes there. Those are North Pole-oriented coronal holes. And here's a view of that in 193 angstroms from the SDO AIA. And you can see some filamentary instability. There's actually a CME that you can see down here in the lower right. Right down here. You'll see that filament wind up and then whoops, it's gone. We'll let that play through one more time for you. And there it goes. Likelihood of solar flares is very, very high. Sunspot 3053 and Sunspot 3055 especially. Also Sunspot 3051. Certainly notable. We did have Sunspot 3054 spontaneously appear yesterday. Sunspot number has come up along with the radio flux and the likelihood of major solar flares. Sticking with sunspots, here's a slightly zoomed in view from 1700 angstroms SDO. Spectacular imagery there in extreme ultraviolet. By the way, extreme ultraviolet light is absorbed by the time it reaches the mesosphere of the Earth. This is why we need spacecraft to view extreme ultraviolet. We didn't know about that until Skylab. That's when coronal holes were discovered in the 70s. So here's your El Teide, Spain, excuse me, ground-based magnetometer. And let's move into the realm of solar flares. These sunspots have been underperforming when it comes to solar flares, and statistically speaking, again, they're very, very likely. Don't be surprised to see an M or an X-class solar flare in the coming day or two. No relativistic particles showing up. Let's take a look at the 131 angstroms wavelength from the SDO. We are heavily reliant on the SDO, and thank goodness it's back. If we do see solar flares, 131 and 94 angstroms are among the best wavelengths to view them. So far, highly underperforming. Next, we like our viewers to be oriented. Here's a star chart. Did you know the sun's about to cross the galactic plane? Yeah, at least from the perspective of Earth. As it moves across the sky on this line known as the ecliptic. The galactic plane is this blue line right here, folks. And if you want to build your own star chart, just head to in-the-sky.org. Mine faces the south as I'm in the northern hemisphere, and that's where the ecliptic is located. This is the all-sky chart, and let's take a look at a solar system forecast. Here's where things are now. We've got a gibbous waxing moon. And there's where things will be in a week. We will have a gibbous waning moon following a full moon, as Mercury and Venus speed away to the opposite side of the solar system. So we've got some great coronagraphs for you here. There were some additional corona mass ejections. I think one of them may have been a stealthy Earth-directed one. Keep in mind that the area between the Sun and Earth is largely swept of plasma at the moment. When you see a big strike, that means that there's going to be a lot of empty space between the Sun and the Earth as opposed to a lot of bunched up plasma, which makes oncoming coronal mass ejections and coronal hole high-speed streams a little bit more geo-effective. Anyway, that's yesterday's coronagraphs. And we've also got today's. So there's today to date. And I think there may be some additional ejecta headed our way. We could expect to see that arrive in about 3 days. Continuing on to view some additional coronagraph data. We've got some missing data here. Here's a view from Stereo A at Lagrange 5 and the SOHO-LASCO C3 at Lagrange 1. So we've paused this right here at this moment. If you look at Stereo A, you can see a little bit of ejecta coming out. The Earth line is right on this line. So that could indeed be earthly directed. If you look at the time stamps, you'll see 2109, 2138, and then whoops, 8 hours of missing data. So, but there was certainly some ejecta coming out at that moment. You can see that little pulsation happening there. If you look at the SOHO-LASCO C3, bring that back to 21. There is a partial halo happening there. I think there is some additional coronal mass ejection material headed our way. So expect some more fireworks coming in about 3 days. I'm excited about it. We hope you are too. We're almost done with the space weather portion of our extended live stream today. Once again, thanks everybody for tuning in on Twitch, on BitChute, and on YouTube. Make sure you stay tuned for our meteorology segment. And I just wanted to end our space weather content with the difference between the SDO and the GOES 16 SUVI. So there's the GOES 16 SUVI. Just give that a minute to load. Again, we are streaming live. We apologize for these technical difficulties here at the Smash News Network, Lee's Busted Name and News. We assure you that the page will eventually load. And let's get to it. Okay. Anyway, you can see the difference in resolution here. That's really what I'm trying to show. You can see how high the resolution is from the SDO. It's just got a little narrower field of view. So you can see this great CME happening down here in the southwestern limb. I would also keep an eye on this filament. This filament is absolutely gigantic and very, very dense. It's a huge absorption feature. And there you can see the difference in the GOES 16 SUVI versus the SDO. That's to last about 2.5 hours. And we're going to move into our bonus features segment. But first, a close-up in color in magnetogram as well as continuum, the SDO continuum visible light and the magnetogram. Here are the bonus feature segments. We've got huge electron anomalies happening here. Check it out. Massive electron anomalies. So this may be the most anomalous we've ever viewed the total electron content. We've got electrons well out of place here. Check out all the electrons down here in the Southern Ocean by Antarctica. Just very chaotic electron contents here. And that includes all the electrons through both plasma spheres, the Van Allen belt. It's the area between your GPS satellite and your GPS handset. You've got a plasma sphere, you've got a Van Allen belt, you've got a second plasma sphere, and then you've got the ionosphere below that. And yeah, electrons highly out of place. We'll let it play through one more time. Some of the most anomalous electron contents that we've ever seen. So GPS is not behaving as expected for the past day. And let's see what else we've got in our bonus feature segment. Some significant charging hazards here as well, over places like Mexico and moving into the Central Pacific Ocean. That's your satellite's community dashboard. There's the GOES electron flux measured by the GOES 16 and 17 in their geosynchronous near equatorial orbits. They use radiography to measure the electron flux at the F layer of the ionosphere. So there's the relativistic electron forecast. NOAA forecasting flat levels here, very low levels of electron flux. There's the 1-year chart. To put it in context, let's take a look at the F layer in vibrational frequency. It's located at 300 kilometers of altitude. And we'll see what we've got. We've certainly got some significant low frequency anomalies happening there, as we've covered for a few weeks, actually. And here's the anomalygram. So some rapid swings there. You can see high frequency to low frequency anomaly shifts. Huge shifts there happening in the ionosphere. That's showing anomaly in megahertz from the 30-day median. So a little bit of space weather happening in the past couple of days. Exciting stuff happening with the sun. Let's show the latest image as we do on our bonus features segments daily, which are typically streamed live to Twitch and shared with the Smash Team at smashamash.com/SmashTeam. There's the latest ionogram, and there's the latest intensitygram. That's 10:30 Universal Time. Last but not least, check out this hydrogen alpha imagery from El Teide, Spain. This filament down here is very noteworthy. Look at how dense it is. It's very, very dark, very, very large, and also multiple other filaments around the solar disk. Likelihood of solar flares very high. Likelihood of additional coronal mass ejections nearly 100%. There's your latest intensitygram and your latest colorized magnetogram. Some exciting sunspots going on. And let's close out with a composite series of images. This is 304, 171, and 211 angstroms. And that is where our space weather video needs to end. However, it's not where this stream ends. This stream continues on. It continues on as we've got some meteorology segment for you here. So let's do it. Normally this is a separate segment. Today, all in one. So here are the jet streams of the Eastern world. Shout out to our viewers from Unda and from over the equator. Give us your recipe for chowder in the comments. We've got some backward jet stream here over the West Pacific and the Indian Ocean. Here are the surface winds of the Eastern world. And we've got a strong low off the coast of Japan. Here are the surface winds of the Americas. It's the Western world. We've got a series of lows here around southern South America, one off the coast of Baja California, and one south of Greenland. Also a strong low here south of Alaska. Here are the jet streams of the Americas. Strong anticyclone, likely associated with clear skies over northern South America. You can see that counterclockwise rotation, the signature of a high-pressure anticyclone in the southern hemisphere. Here are the jet streams of the central world, Europe, Africa, and the Middle East. The jet stream blowing backward here over a large portion of the planet. No, the jet stream's not going to kill you. No, CERN is not controlling the weather. Here are the surface winds of this side of the planet. Shout out to all of our viewers who've taken physics. Shout out to all of our viewers who haven't taken physics. It's highly recommended that you do. Did you know that you can take MIT's physics courses online for free? Yep, you can get all the study materials, the tests, etc. on MIT's website if you haven't taken physics. And if you think the universe is, if you think everything's electric, please take physics too. We have the term electric for a reason. A styrofoam cup is not electric. Next, here is your weather.gov map. The heck do we have there? Flash flood warnings. They're happening in eastern Colorado. And some excessive heat warnings in large portions of the south central U.S. Some good surf likely happening once again in Hawaii, as we've got some small craft advisories there, or gale warnings. I think those are gale warnings. Small craft advisory, I don't know. It's windy. And if you've got an offshore wind, it makes waves taller and steeper, making for better surf. An offshore wind is what you want. And checking out the lightning scenario, we've seen very high levels of lightning. Who knew that July is the most lightning-prone month of the year? It's certainly showing up. Let's take a look at a real-time lightning map since we are streaming live today. We've got some terrestrial lightning shout-outs in the U.S. Terre Haute. You've got a strong active cell to your southwest. Excuse me. So there's a very strong cell. Also north of Decatur. Those are the teeth of the current storms. And check out lightningmaps.org when you hear thunder. It could save your you-know-what. Lots of European lightning happening here as well as lightning from Russia, which is probably Putin's fault. Just kidding, folks. Putin doesn't control the weather either. Now we're going to bring up a 72-hour temperature anomaly forecast here since we're getting such hot temperatures in the south central U.S. Just give that a minute. There we go. There's a great GIF animation for you. And some huge temperature swings happening there. Ignore that dialog box. Go away. There we go. You can see that's all going to subside, and you're going to have some huge temperature gradients. Look at the sudden temperature swings over Texas. That's your 72-hour GFS temperature anomaly forecast in degrees Celsius. So those dark purple areas, those are like 12 degrees Celsius below. And the pink portions, that's about 12 Celsius degrees above normal. Again, some wild swings happening there in the U.S. temperature anomaly forecast. Here's your pressure and precipitation forecast for the same period on the same model, the GFS model, and you can see some severe weather expected for the southeastern U.S. So lots of red showing up there. Places like Tennessee, the Carolinas, Georgia, Alabama, Mississippi, and New Orleans, who constantly gets pummeled by heavy weather. And let's continue on. And here's your pressure map from windy.com. They've got a great mobile app, by the way. Maybe check that out if you like. Windy.com. Huge anticyclone here off the coast of Ireland, making for clear skies in a large area. That's almost entirely clear skies over that portion of the planet. I would bet the farm on it. And again, you can see that strong low south of Greenland, south of Alaska, etc. Let's move on. Let's try to move on and hope that I regain control of my own PC. Next, we're going to look at the radar.weather.gov map. There you go. Let me press refresh. Okay. Thank you. Anyway, that's the current radar environment. Let's look at the lower 48 here. Some technical difficulties happening there on radar.weather.gov. Let's take a look at the clouds and fog situation, the shortwave radiation map. And here's the water vapor. Here isn't the water vapor. All right, and we've got that for you. No worries. There's the water vapor map. And let's hope things work out a little better on the recap here. We'll go back. So there's the water vapor scenario. That should help you out if your Doppler is not giving you a clear picture. I don't know what the heck is going on with the Doppler. That is defunct. Anyway, that's where the current precipitation is likely to be happening. Here's a shortwave radiation map. And there is the water vapor. That should clear things up. We hope you're able to forecast your own weather. Thanks for tuning into the Smash News Network, least busted name in news. Again, don't forget to press like, subscribe, share, etc. We'll see you soon. And may that solar wind be at your back.